North America, a vast and diverse continent, faces a hidden threat. This threat is not immediately visible to the naked eye, but its impact is profound and far-reaching. The land itself is sinking in many areas. This process, known as land subsidence, is a gradual yet relentless force that reshapes the landscape. This phenomenon, known as subsidence, poses a serious challenge. It affects both urban and rural areas, leading to cracked foundations, damaged infrastructure, and even the collapse of buildings. From coastal cities to inland plains, the ground beneath our feet is shifting. Coastal areas are particularly vulnerable, as the combination of subsidence and rising sea levels can lead to devastating flooding. This essay will explore the science behind this phenomenon and its implications for our future. Scientists are working tirelessly to understand the underlying causes of subsidence and to develop strategies to mitigate its effects. Subsidence is a gradual process, often imperceptible in our daily lives. It can take years or even decades for the effects to become noticeable, but by then, the damage is often extensive and costly to repair. However, its cumulative effects are alarming. Over time, the ground can sink several feet, leading to significant changes in the landscape and increased vulnerability to natural disasters. As the ground sinks, the risks of flooding, infrastructure damage, and ecosystem disruption increase. Flooded streets, collapsed roads, and broken utility lines are just some of the visible signs of subsidence. Understanding the causes and consequences of subsidence is crucial for developing effective mitigation strategies. By studying the patterns and drivers of subsidence, scientists and policymakers can work together to protect our communities and ensure a sustainable future. Land subsidence occurs when the ground level lowers. This phenomenon can be observed in various parts of the world and can have significant impacts on the environment and human infrastructure. This can happen for various reasons. Natural processes like the dissolution of limestone or the melting of permafrost can cause the ground to sink. However, human activities are often the primary drivers. One major culprit is the excessive extraction of groundwater. As cities and agricultural areas grow, the demand for water increases, leading to more intensive groundwater pumping. Beneath the surface, aquifers hold vast reserves of water. These underground layers of water-bearing rock or sediment are crucial for supplying water to wells and springs. When we pump out groundwater faster than it can replenish, the ground above compacts. This is because the water in the aquifer supports the overlying ground, and when it's removed, the ground loses its support. This compaction leads to subsidence. The ground slowly sinks, which can cause a range of problems, from minor cracks in buildings to major shifts in the landscape. Imagine a sponge filled with water. As you squeeze the sponge, it shrinks. This is a simple way to visualize what happens underground when water is extracted from an aquifer. Similarly, the ground compresses when water is removed from underground spaces. The soil particles are pressed closer together, reducing the volume of the ground. This process is often gradual, but its effects can be dramatic over time. Buildings can tilt, roads can crack, and entire areas can become more prone to flooding. Coastal regions and areas with heavy agricultural irrigation are particularly vulnerable to subsidence caused by groundwater depletion. In these areas, the combination of natural and human-induced factors can lead to significant land sinking, affecting both the environment and human activities. Addressing land subsidence requires careful management of groundwater resources, urban planning, and community awareness. By understanding the causes and effects of subsidence, we can take steps to mitigate its impact and protect our landscapes and infrastructure for future generations. The Earth's crust is not a single solid shell. It is broken into massive pieces called tectonic plates. These plates constantly move and interact, creating mountains, valleys, and earthquakes. Tectonic activity also plays a role in land subsidence. In some areas, tectonic plates collide, causing the land to uplift. In other areas, plates move apart or slide past each other. This movement can create basins that slowly subside over time. While tectonic subsidence is a natural geological process, human activities like oil and gas extraction can accelerate it by removing underground material. As if land subsidence wasn't enough of a concern, we are also facing rising sea levels due to climate change. The warming of our planet causes glaciers and ice sheets to melt at an alarming rate, adding more water to the oceans. This combination of sinking land and rising seas spells trouble for coastal communities. Areas already experiencing subsidence are more vulnerable to flooding and erosion. The encroaching sea can inundate low-lying areas, damage infrastructure, and contaminate freshwater sources. Section 5. Crumbling foundations, infrastructure at risk. Land subsidence poses a significant threat to our infrastructure. Buildings, roads, bridges, and pipelines are all designed to rest on stable ground. When the ground sinks, these structures can experience stress, cracks, and even catastrophic failures. The economic costs of repairing and replacing damaged infrastructure are substantial. Moreover, subsidence can disrupt essential services like transportation, water supply, and sewage systems. This disruption can have cascading effects on communities and economies. Section 6. Turning the tide, sustainable water management. Addressing land subsidence requires a multifaceted approach. One crucial step is to implement sustainable water management practices, particularly in areas heavily reliant on groundwater. Reducing our dependence on this precious resource is essential. We can achieve this by promoting water conservation measures, exploring alternative water sources like rainwater harvesting and desalination, and implementing stricter regulations on groundwater extraction. By using water more wisely, we can alleviate the pressure on aquifers and mitigate subsidence caused by groundwater depletion. Section 7. Engineering solutions. Adapting to a changing landscape. While preventing further subsidence is crucial, we must also adapt to the changes that have already occurred. This adaptation requires innovative engineering solutions to protect existing infrastructure and design new structures that can withstand subsidence. This could involve retrofitting buildings with foundational supports, constructing elevated roadways, and using flexible materials in pipelines. By embracing resilient design principles, we can create infrastructure that can better withstand the challenges of a sinking landscape. Section 8. A call to action: collective efforts for a sustainable future. The issue of land subsidence highlights the interconnectedness of our planet and the profound impact of human activities. Addressing this challenge requires a collective effort from individuals, communities, and governments. We need to raise awareness about subsidence, support scientific research to better understand its complexities, and advocate for policies that promote sustainable water management and resilient infrastructure development. By working together, we can mitigate the risks and create a more sustainable future. Section 9. Our future on solid ground: a vision of hope. In this chapter, we delve into the possibilities that lie ahead, envisioning a world where our cities and communities are not only resilient, but also thriving in harmony with nature. The challenges posed by land subsidence are significant, but they are not insurmountable. By understanding the science, embracing sustainable practices, and fostering innovation, we can turn these challenges into opportunities. Engineers and scientists are already working tirelessly to develop solutions that will secure our future. We can chart a path towards a more resilient future by integrating green spaces into urban planning, utilizing advanced technologies, and promoting community involvement. Imagine cities where every building, every street, and every park is designed with resilience in mind. Imagine a future where cities are designed to adapt to changing ground levels, where buildings can adjust and infrastructure can flexibly respond to the Earth's movements. This is not a distant dream, but a tangible goal we can achieve through innovation and determination. In this envisioned future, water resources are managed responsibly, ensuring that every drop is used efficiently. Advanced irrigation systems and sustainable water management practices will become the norm, safeguarding our precious water supplies. And where human activities exist in harmony with the natural environment, parks and green spaces will flourish, providing habitats for wildlife and recreational areas for people. Sustainable urban living will be the standard, not the exception. This vision of a future on solid ground is within our reach if we act decisively and collaboratively. Communities will come together, sharing knowledge and resources, to build a future that is both resilient and sustainable. Celebrating our achievements will inspire further progress. Let us rise to the challenge and ensure that future generations inherit a planet where the ground beneath their feet is stable and secure. By working together, we can create a world where families can thrive, children can play safely, and our environment is protected for generations to come.